one of the type of algebraic expressions. One of the type of algebraic expressions is polynomials. Means what I'm trying to tell is the algebraic expressions actually will be of many types. Is if you have a variable inside it, automatically that will be an algebraic expression. But particularly polynomials, algebraic expressions to become polynomials, there are certain conditions. Okay. Like for example, in rational numbers, we have rational numbers means so many types. All of those together we'll call rational numbers, like integers, fractions, negative side of the integers, like positive side integers. Everything is rational numbers only. But particularly in that, suppose if you're talking about integers, integers is a part of that rational numbers. Like that, polynomials is a part of algebraic expressions. It is one of the type in algebraic expressions. Means simply to tell, algebraic expressions is a head. Like rational numbers is a head for integers, whole numbers, all that, fractions, negative numbers, decimals, all that. Like that, here algebraic expressions like means all the terminating decimals and non-terminating recurring decimals of their part of rational numbers. Like that, here separate polynomials is just part of algebraic expressions. It is one of the types, simply put it. So algebraic expressions is a big thing. In that, polynomials is one part. So next thing is like, then in which cases we can tell an algebraic expression as a polynomial. In which cases we can tell an algebraic expression as a polynomial. There are certain conditions. Conditions means, like by looking at algebraic expression, we should first the question of the one important one marker is there will be 4 options and they'll ask us to tell which of the following is not a polynomial or which of the following is a polynomial. So the conditions we should check is the variable whatever present in the expression, like variable is x, y, z or anything, whatever variable they are using, that variable degree will be there or power in each term. Means polynomial means we know many terms will be. It can have single term means monomial, 2 terms means binomial, 3 terms means trinomial. Like that, simply more than 3 means polynomial. So then terms, how to recognize is terms will be separated with plus and minus sign. So whatever any term, like each and every term contains a variable. For that variable degree will be there, that is power. That power should be always the variable degree or power in each term always should be positive whole number, or simply whole number. I can positive whole number means because 0 is also a whole number, so simply should be a whole number. This is the main condition. So variable, so what is the meaning of that? The meaning of the A statement is variable power, that is variable power cannot be negative. Variable power cannot be negative number or a fraction or a negative rational number. Or simply decimal also, because once it's a fraction means 1 by 2 is there means automatically it will be 0.5 or minus 1 by 2. Like that, negative terms should not be there on the variable power. If they are there means for the variable, that is just an algebraic expression but not a polynomial. So like this. Main thing, simply variable power should be 100% a whole number, like 0 to any number. If it is 0 also, not a problem. We'll call it as a constant polynomial because when a term has no variable at all in the given polynomial means we can write x power 0 like this. So for example 5 is there. 5 is not a, you can tell it as a polynomial but a constant polynomial. How? Because this has no variable inside. If you want, how can I tell polynomial? I can write beside 5 x power 0. X power 0 is 1 times 5 into 1 is 5. So because of that reason, so simply a number is there means you can call it as a polynomial by writing a variable beside it by writing power 0. So degree of a constant polynomial is 0 because the reason is the variable beside it actually is not there. We wrote it and we kept it power 0. Power 0 means it's 1 only. So this is important one marker. Degree of a constant polynomial is dash. Means 1 will, sorry, 0 we should write it. Constant polynomial means some number like 10 or 11, minus 50, 20, anything. So if you write just beside x power 0 by writing it by placing a variable x or y or z of your wish and write it, if you write a power 0, automatically it will become a polynomial in power degree 0. So degree of, because of that reason, constant polynomial means some number can make it like a polynomial by writing power variable power 0 basically it. So degree of the constant polynomial is 0 because degree means we have to check the variable power only but not the number power. 5 power 1 we cannot check. 10 power 1 is the degree we cannot tell. Degree of the polynomial means always variable power only. Highest power of the variable present in the given equation is the degree of the polynomial. So these are the condition. Main easy way to remember is the power should be always positive or from 0. So simply if you see anywhere negative power or negative fraction like a fraction or a negative rational number means simply that particular expression, that particular algebraic expression is not a polynomial because once the variable contains such kind of negative numbers as a degree or power or fraction or minus negative rational number, simply it is not a polynomial, it is just an algebraic expression.
Okay, sir.
Okay,
I understood.
Pranavi?
Yes, sir. I understood.
Okay, Pranavi. Now next thing is Pranavi, types of polynomials already we know it. Types of polynomials, if we have a single terms will be separated. In an algebraic expression, terms will be separated with the plus minus sign between them. Like for example, if I write an algebraic expression like this, ax square plus bx plus c, here it is a trinomial. So terms are separated by plus. Like this is first term, ax square is first term, bx is second term, c is third term. It's a trinomial. 3 terms are there. Okay, Pranavi?
Yes, sir.
So like that, Pranavi, it is like it's any doubt? No doubt. No? Like if we have monomial means single term. This is 3 terms of trinomial. Monomial means like let us write ax square. It's a monomial. One term only. Ax square plus bx. It's a binomial.
Yes.
Like ax square is one term plus bx is second term. It's a two term. Now next thing is about degree of the polynomial. Okay. So degree of the polynomial, I think you remember. Degree of the polynomial is whatever each and every term we should check it in the polynomial. Each and every term variable power will be there, no? Highest power of the variable present in the given expression. Given terms of expression. So for example, Pranavi, if I write an algebraic expression like this, ax cube plus bx square plus cx plus d. Here A, B, C, D, A, B, C are actually, A is the coefficient of x cube, B is the coefficient of x plus C is the coefficient of x. So 3, 2, 1 are the powers of x, that is variable power. D power, beside D also can write x power 0 if you want, not a problem. So
Yes,
if
sir.
you see the power is 3, 2, 1, variable powers are in the decreasing order actually. So highest is 3. So degree is 3. So if degree is 3, Pranavi, that particular polynomial is called as cubic polynomial. Suppose in the first expression, in the top one which I wrote, this one. This one, if you observe, Pranavi, highest power of the variable present in each term, if you observe, highest ax square is one term, bx is one term, c is one term, highest is x square, x. Here, if you want x power 0, you can write. So x power 2, x power 1, x power 0 is highest is what 2. So degree is 2. So if degree is 2, that particular polynomial is called as quadratic polynomial. So degree is 2, what we will call, Pranavi, that particular polynomial?
Quadratic polynomial.
Yes, Pranavi, that is correct. So now fine, like that, there will be 4 degree, 4 degree, 5 degree, 6. We'll mainly name them up to cubic polynomials till 3. 4, if it is there, means biquadratic we call. Quadratic is 2, biquadratic means double of that, 4, like that. So here, but mostly we'll remember up to cubic polynomial. Linear, now next is one, if suppose degree is 1, ax plus b, let us write one more expression, ax plus b. Ax plus b, if you observe the terms, Pranavi, it's a binomial here actually, but variable is x, so it has power 1. B, if you want beside, you can write x power 0. So x power 1, x power 0, highest is what? 1. So if degree is 1, Pranavi, that polynomial is called as linear polynomial. That is the reason why in linear equations chapter, we have x power 1, y power 1. We call linear equation in 2 variables. Because linear we call, because the reason is x power 1 only, y power 1 only, degree is 1. Okay, Pranavi?
Yes, sir, I understood.
Okay, Pranavi. So degree of a biquadratic polynomial means it is 4, because the reason is quadratic is 2, biquadratic means x power 4, like that power. So it's a biquadratic polynomial. So this this is about the types of polynomials. If simply more than 3 terms are there, means it's a polynomial. So particularly polynomial with 1 term, we'll call monomial. Polynomial with 2 terms is binomial. Polynomial with 3 terms is trinomial, like that. Degree has so Pranavi, one more point here. Degree like a degree and type of polynomial is nowhere related. Means if you write monomial also, you can write degree how much you want also. Like for example, you want to write a monomial with the degree 35. Means what? I can write ax power 35. Ax power 35 means this is a monomial only, but degree I wrote it 30. Okay, Pranavi?
Yes, sir.
Means simply what I'm trying to tell is degree and type of polynomial like nowhere related. You can write if you write monomial, you can write power how much you want also. Power also. Degree you can write 100 also, not a problem. So in that way, this is one thing for me. And now we'll go to yes, we'll go to the first exercise.